Hello everyone and welcome back to another video, and I'm just gonna talk about something that I found out, and I hope that this is not crashing. So this is on the second Lightning, the one that's really sketchy, that doesn't really work unless you give it the right amount of mounting pressure. So this card has Samsung memory and not Hynix like the other cards that I tested. And this one, like I've ran Samsung cards from this generation before, but this one is doing something that I haven't really noticed yet. I don't know if it's only this card or if it's something in general that I just kinda missed. So you see it's running Firestrike right now at 2450. It is pretty much on the edge. It might actually crash, but I had it pass at these clocks several times. But this kind of looks like a pass because of it crashing. It usually happens in GT1. I took core down a bit. I can actually push that another 25 megahertz. No, with the water cooling. Still only 1.15 volts. I haven't flashed the unlocked Lightning BIOS onto this yet, where I can go to 1.2 volts. But I think I'm going to. But yeah, so the thing is, you see right here, like, it's not artifacting, it's not doing anything weird. It's running 2450 on the memory, and okay, yeah, you saw that black frame, it's slightly unstable, but it passes, basically. I had it pass several times. So, you should... Oh, I don't think you'll be able to see this. If I enable the light, yeah, you can kind of see it. That memory module down there that I put some thermal paste on so you can read it easier, like that's a Samsung memory module. So this card is running Samsung memory. So yeah, and actually we are at the last step of the test right now. So I should start talking about what I found out with this. So Samsung memory, there's a thing about it when you do liquid nitrogen overclocking. Where you have, like you see on some extreme overclocking cards, actually my 780 Ti matrix does have that, as far as I know. They have a memory heating system. And the question is, why would you want a memory heating system? Usually you want to keep things cold. And yes, that is mostly the case, except for some Samsung memory, like Samsung memory on some cards. Okay, we passed. The score is really low because I took the core down. But yeah, you see it passes. So the thing with these Samsung memory modules is, and I only thought this is on liquid nitrogen, is when you take them too cold, like when you cool them down, when there's an LN2 port on the GPU, cooling down the entire thing, like the memory is getting cold as well. And there's an issue there, that when the memory gets too cold, it actually gets really, really unstable. So there's a memory heating system on some cards. This one doesn't have it, I think. I don't think it has. And yeah, so the memory heating system keeps the memory warm so that it gets more stable. And I thought that this only happens when you go like really low on temperatures, like liquid nitrogen, dry ice. But this card is actually doing that. So this 2450 does not pass if the card is cold. I specifically removed the fan cooling the memory to make this more stable. So when I just let this sit, or maybe if I reboot the card, I guess we could try to demonstrate that. Let's restart it. So what I noticed is when this card is cold, when you just boot it up, it will not pass 2450 on the memory, it will only pass 2400. But you just saw it passing 2450, because I ran like several just passes of Firestrike and heated up the card, or also the memory, and then it suddenly started passing 2450. Like, I don't know if just rebooting it once is enough to make it cold again. It did crash once before after I rebooted it, but that was, well, after running a lot shorter than it did now. Okay, we still have applied. Let's go into 3D Mark once more. No, we don't want Steam. Like, if I'm lucky, this will crash now. But, like, the card has been running for some time, it might still be warm enough. I didn't really let it cool down, I just rebooted it. But that was enough to crash it the first time. So let's see if this crashes again. And while this loads, I guess I can talk some more about the card. So, I previously talked about this, like, I also said it in this video. This one has some serious mounting pressure problems. And actually, this is loading up now. So the card has some mounting pressure problems. It does not work on the heatsink that it comes with. It does basically not work on any heatsink unless you give it the exactly right, it needs a very specific amount of mounting pressure to work. And I only had the Accelero Extreme 4? Yeah. That it worked on. Because that just happened to have the right amount of mounting pressure. And it looks like the card is still too warm. This looks like it will pass. So yeah. Oh, nope. Now it crashed. Okay. You see? We let the card cool down a bit. And it doesn't even make it past GT1. And this is not the core crashing. The core can push more. Like it, I had it pass at 25 megahertz above what it is right now. So yeah, there you have it. It's crashing. Oh, that's nice. The demonstration worked. So yeah, and some more stuff about the card is just like, yeah, it only ever worked on that one heatsink. And I finally got it working on the water loop, which isn't really that hard because those screws have a very, like, I can be very precise with the mounting pressure here, so I was just able to adjust it to something where it would work. But the one thing is, you might have seen it with the temperatures. The temperatures are kind of high, and I don't think you'll be able to... yes, actually you can see it a bit. There's still the IHS in there. Because if I remove the IHS, this sucker will not boot up. Like, okay, it will show an image, but it will artifact like it's broken. Yeah, so it does need the IHS to work. Probably because of that mounting pressure thing. Like, if you remove the IHS, the contact area is smaller, and that probably results in, like, the edges of the substrate of the die, not the die, the substrate of the GPU, the little PCB that the GPU sits on that's connected to the board of the card. Like, apparently the edges of that need to be pressed down, and that doesn't happen if I remove the IHS, because then only the GPU part in the middle is getting pressed down. So I have to run the IHS, which sucks, because it is... I saw it climb to 57 degrees. That's not good, because the other 580s that can run without the IHS max at something like 48. That's 9 degrees. That's a lot. So at this point, the normal air heatsink is actually just a... Yeah, like, there's not really that big of a difference. I'm still gonna keep it on the water cooling though, because I will flash the... Like, this is... You see those throttleizers are missing. This is the twin thrower on the Lightning PCB. But this also comes with a BIOS that has less voltage headroom. But I do have a full Lightning. So I can just use that BIOS on this card. This also has dual BIOS, so I don't even risk breaking it. So I can just use the Lightning BIOS on this and go to full voltage, and then the water cooling might be worth it. As of now, it's not really doing a lot. Like, I got those extra 25 megahertz out of it. Barely. It's also really on the edge. But yeah. And one more thing, you also see it's in the 8X slot, not the 16X slot. I don't know what it is. Literally just using that screw to screw in the cards. That made all the reference cards and the DirectCU2 work again in the 16X slot. The MSI ones, this one, the other Lightning, and the 560 Ti448, all of them do not work in the 16X slot. I don't know why. They only take the 8X one. So there's something that MSI did with their GTX 500 series cards, because they have a 460 Hawk from MSI. That one works as far as I know. I haven't tested it in a while, but the last time I tested it, it worked. So something's going on with MSI's GTX 500 series cards that really make them not like the 16X slot on X370. Which, I mean, it's not really that big of a deal. Like, this is a 580. PCI Express 2.08X, it's probably fine. Probably. I will still lose some score, but it's not gonna be a huge drop. But if I ever want to like bench for HW bot, it would be nice to have them working in the 16X slot, especially when I do SLI with the two Lightnings, which I'm still planning to do, but I don't have a power supply ready right now. Well, actually I have, I'm just too lazy to set it up. So yeah, that's about it with the card. It does work now. I'm gonna just do some more benching. I don't know if it's gonna turn into a video. I'm just kinda in the mood for, yeah, like literally just like bench, fire, strike, and chill on an interesting card. Like, this is really, like, even with all the issues, I really like how this card does. Like, it's the best core I have. The memory heating thing means that the memory on this is not that bad after all, because if it heats up, like 2450 it's still 100 megahertz off what the other Lightning did at peak, but it's way above the direct CO2, which is also Samsung. So I'm actually now quite happy with the memory on this, as long as you can keep it hot. Then also, the VRM on this thing is really, really nice. When I benched the reference card, the VRM on the back on the PCB, if you touched this area, you would, well, you wouldn't get a burn, but like it would hurt. This one, when it's under full load, it's basically as warm as the back of the core. It's really, really like, it's warm, but not hot. So yeah, this VRM is really, really nice. Though I haven't pushed it to the limit yet because not full Lightning BIOS. And I should also like look for a PDF that explains how all those switches work, because there is a overvoltage switch for pretty much every rail on this thing. I just don't know how they work. Like, what happens if you flip them? I need a manual for this card, so I'm gonna try to look up that. And I think by now I am rambling too much. This was supposed to be just a short video, and now it's 13 minutes long. Huh. So, yeah. Thank you for watching, hope you enjoyed, and until next time, goodbye.